In this example, we're given another image. This time it's of a building and a surveyor measuring the height of the building. So they find that the height of the building is 50 feet right here. So that's 50 feet. It's kind of messed up the picture. But 50 feet tall for the building. The angles, there's two angles here. So the angle of elevation from the surveyor is 43 degrees. And the angle of depression down here is 16 degrees, and we are asked to find the length x, right, of the linear distance here on the lower side of this triangle from the surveyor to the base of the building. So we need to kind of gather our thoughts here. Number one, we see that these two parts of this angle create like a single angle, which we could call alpha maybe, and this angle alpha's measure is going to be 43 degrees plus 16 degrees, and so altogether that's 59 degrees. All right, we know the opposite side from that angle, so I'll do it in red. So we know that we'll call this A. A is equal to 50, right? And if we just start giving everything else names, we can call this one B. Right? So this side B is unknown. That's our X. And a nice question would be, if this angle is beta, do we know beta? So can we determine beta? If we can, then we'll have all the information that we need to apply the law of sines. Okay, because we'll have two pairs of angles, opposite angles and sides. Well, one of them is an unknown, but we'll know 3 of the 4. And so we'll be able to compute that. And it turns out we can figure out beta because of the way we were given this angle, right? So this is a right angle for our angle of elevation. If this angle is 43 and this angle is 90, then this angle has to be what's left over, right? So this angle beta to make a triangle. So they have to add up to 180, right? So the angle beta must equal 90 degrees minus 43 degrees. Just to make sure that that right triangle adds up to, that all the angles in that right triangle add up to 90 degrees. And then when we subtract this, we get that this must be 47 degrees. So there's our angle beta is equal to 47 degrees. All right, let's apply our law of sines. Remember, the law of sines, I labeled these sides with capital letters instead of lowercase letters. So let's fix that. So lowercase b and lowercase a. Now, the law of sines says two different things. In this case, it says that sine of alpha over a should be equal to the sine of beta over b. That's perfectly fine. But b is our unknown, and it would be nice if b was in the numerator. So the other way you can write the law of sines is that a over sine of alpha is equal to b over sine of beta. All right, and if we want to solve for b, we can do it before we do anything else, right? We can just multiply over, cross multiply, sine of beta to the other side, and that will isolate b. So now we have that b is equal to what? A times the sine of beta divided by the sine of alpha. And now we can plug in all the information that we know, because we know all 3 of these numbers on this side, right? So what we end up with is that our b is going to be equal to a, so that's 50, times the sine of beta. Beta was 47 degrees. It looks like a 47 degrees, right? So sine of 47 degrees, all divided by the sine of alpha. Alpha was 59 degrees, so sine of 59 degrees. All right, and so once we compute this, we will know the distance, x. So, but yeah, by the way, this b, this is actually x, right? We'll know x. So let's go to GeoGebra, type this in, and see what we get. So 47 degrees and 59 degrees. All right, so we're going to have 50 times sine of 47 degrees. Do we make sure that this is in degrees? We'll have to check it in a second. Divided by sine of 59 degrees. Okay, we get 42.66, but we need to make sure that these are in degrees. So you can click Here, oh, there you go. Okay, once I hit enter, I should have just hit enter. You can see that they have degrees there. If you don't want it in degrees, I guess you have to change it to radians, but we do want degrees, so this is exactly right. And so our answer then is that that distance to the base of the building from the hill is 42.66 units, and I believe it was in feet, right? So 42.66 feet. And so that's our answer. So I'm going to round again here, but 42.66 feet. There's the distance from the surveyor to the base of the building. Done using the law of sines.